Okay, recording is started. So we're doing some more mental flexibility in this talk. We just went over the rules, as always. When we say mental flexibility, this basically translates as having lots and lots of different approaches to things, and what that is. Many, many approaches. So that's the point, having lots of ways to try stuff. Okay, let's try one. And again, here's the copyright notice, as always. These are all from GMAT Prep this time. There's none from any other source. So, free GMAT Prep software, again, not the paid question tags, that's important. The allowed questions are exactly the same as what's allowed in the forum. Exactly the same. Here is the first question of the day. Okay, this one. Remember where you find your multiple choice options. Remember where those are found. Those are found there. Okay. Okay, if you are still working at this point, you should be absolutely sure that you are going to get this right if you keep working. If not, you should just cut it. So there's pig20, SNDDYLNG at Hotmail. Go ahead and pick something. Okay, so remember the theme of today is mental flexibility. So what this means, I mean, most people don't terribly much have to be reminded of textbook methods, you know, like the ways that you learn in school to do math. So there's not going to be much emphasis on that today. We might even skip a few of those, depending on, you know. But let's talk about this. Remember, the emphasis today is on non-textbook ways to approach these things. So, who's got a way to approach this that isn't calculating a probability so much? Does anybody have ideas? I mean, think about probability. Like, how did you first learn what probability was way back in the day? Like, when you learned probability in, I don't know, 6th grade, 7th grade, they ask you questions like, if you pick a random letter from the English alphabet, what's the chance that it's like A through H? I mean, yeah, you just list them and you just count. Because, like, okay, I mean, what I'm going to do right now is I'm just going to make a giant list of some of the more common alternative methods. I mean, this is not really, I wouldn't call it exhaustive, but here's a list of common alternative methods that we've treated in many of these sessions. Okay, you have backsolve, which means start from an answer choice and just see what you can do. You have plug in, which is also known as smart numbers. You have common sense estimation. You have make lists. Those are the 4 pretty big ones. So just what can help, by the way, because okay, here's the thing. Like, a lot of people, when we have these sessions about alternative methods, people are like, oh, well, okay, that's pretty easy, I can do it. But then when it's time to go take the exam, a lot of people find that the primary challenge is realizing that these are things. Like, you know, people are good at doing this in their living room, and they're very good at doing this in a session like this one where they're being prompted to do it. But just something for you to think about for test day. I mean, the primary challenge is going to be remembering to do these on test day, or even remembering that these exist on test day. So what you can do to address that, it's pretty simple but brilliant in its simplicity. You can just make a list of these and just write it down on your paper. So just actually just put these down. As soon as you get that yellow plastic pad, just write these down in a list. So that way you never have to come up with these cold, and you can just look at your list. So when you get your yellow pad, when you get it, write this list down, and then if you get stuck on a problem, just go down the list. It's kind of cool. Because now you never have to come up with these cold ever again. Kind of neat. Okay, so anything on this list? How about that? How about common sense estimation? I mean, probabilities have a certain angle of common sense, right? Because look at the answer choices. I mean, you got A, which means very, rather unlikely, and you have B. You have E, which means super likely. I mean, you got 6 people, and so let's just think about common sense for a second, because here's the answers that you guys pick. What's interesting about this is the 2 most popular answers are the 2 super extremes, like the smallest probability and the biggest one. So, because common sense shouldn't really tolerate both of those. There's no event in the world that could reasonably be a 1 out of 15 chance that could also be a 1 of 3. I mean, those are very different things. So let's think about this for a moment. Let's just do common sense estimation with this. Draw an arrow over here. Okay, common sense estimation. Well, we have 6 people, and what is the only way to succeed in this situation? What constitutes success? Yeah, you have to pick 2 exactly specified individuals out of 6, and you have to pick both of them. I mean, does that seem like it's very likely to happen? I mean, definitely not 1 of 6 or 1 of 3 times. I mean, there's just absolutely no way it's going to happen that often. Because, I mean, there are lots of ways that you can pick a pair of people. So, but clearly not very likely. So at the very least, just by pure common sense, you should be able to knock off D and E. So, common sense says no and no. No way, don't do it. Okay. By the way, there's another reason why E is wrong, which is quite apart from the whole common sense thing. Here, let me show you what I'm talking about. Yeah, right, when you the chance of even getting, well, the chance of getting just Joshua would be 2 of 6. It's not 1 of 6 because you actually picked twice. But you do have a point. You can calibrate by thinking about that. But here, let's say that you did not even read English. And so everything was gone except for that. Alright, or let's say, it hasn't rained here in LA for a while. So let's say the rain came and washed away everything except that. Okay. Let me tell you a story about this. The story is that you already know the answer is not 2 out of 6. Don't do it. Don't do it. Yeah, it's the don't do it answer. Yeah, right? I mean, if you have anything like this, I mean, the principle at work here is you will never just do simple arithmetic with given numbers. Not going to happen. I mean, even in the most basic problems. I mean, you might think something like this would happen in problem 1 or 2 out of the OG, and you'd be wrong. I mean, even the problems at the very beginning of the OG are already doing pretty significant mathematics, if they do. If it's computation, you'll at least have to contend with more than just simple arithmetic. So you can absolutely trust this. It's not going to be a thing. Like if you have a question that's like blah 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 3 yada 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 5 x x x x x x x. If that's the question, then the answer is not 3 plus 5. The answer is not 3 minus 5. The answer is not 5 minus 3. The answer is not 5 times 3. The answer is not either of the divisions. And the answer is not 5 to the 3rd. And the answer is not 3 to the 5th. That's a lot of things that the answer is not. Yeah. Because those last two, in case you don't know what those are 5 to the 3rd and 3 to the 5th. Never. Not going to happen. So you can eliminate those before you even use your brain. It's kind of nice. Okay, so E is double bad. E is the don't do it answer, and it is also ridiculous by common sense. So, and yet, it was still the second most popular answer on the whole screen. I mean, I'm going to guess that a lot of people who picked it probably just literally divided 2 by 6. Don't do it. Bad idea. Okay. Now let's talk about a method that will actually solve the entire problem. So we do know that those are common sense, not D, not E. But, all right, here's your list again of names. What else in this list will work? Oh, it's so big. What? Why is it so big? There. What else in this list will work? Let's just make lists. Yeah, that's the whole question I asked earlier about probability in grade school or whatever, because that's how you used to define probability before you got all fancy with stuff. Before you learned all these weirdo, methods of multiplying fractions together. Yeah, what probability was at the very beginning. The original, I mean, because these kinds of things don't often work for probability. Back solve and plug in. I mean, because for the most part, you can't start from a probability and go anywhere with it. Like if I tried to back solve, I have nowhere to go. I can't start from 1/9 and do anything with it. And then there's no plugging because nothing is unknown. So, and for the most part, these things are not very useful on probability. You won't get much mileage out of these on probability. So, but yeah, make lists, absolutely. I mean, this should work almost every single time. And there's a comment in here, by the way, I want to make a disclaimer about our practice test versus the OG, but we'll get there in a second. I mean, this is what probability is. I mean, you should almost always be able to do this. And what's neat is that the only exceptions generally are the simplest problems. So here you can totally do it. You only have 6 workers. I mean, let's say our 6 workers are, let's make a list of all the different ways to pick 2 people. I mean, and let's just say that our people are, I mean, it's annoying that these names start with the same 3 letters. Like they both start with J-O-S. So you know what, the heck with that. Let's just call the people 1, 2, 3, 4, 5, and 6. And then let's say Joshua is number 1 and Jose is number 2. So there. Because I mean, okay, Now the deal is, the sort of challenge I'm going to throw down on the table is you should be able to make this entire list in about 10 seconds. Maybe 15 seconds. If it takes you longer than that, you should practice making lists. Yes, that will be boring. It'll be incredibly boring, but you need to be able to do it. So let's make this list. All the different ways to pick 2 people. Well, we can pick 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. 2 and 1 we don't need. We already have 1 and 2. So that's 2 and 3, 2 and 4, 2 and 5, 2 and 6. Then we've got 3 and 4, 3 and 5, 3 and 6, 4 and 5, 4 and 6, and 5 and 6. If you allow these to be in the other order, it's actually not going to matter because you'll just have everybody again. Like you would also have 2 and 1, and you would also have 3 and 1, and you would also have 4 and 1. I mean, you would just have 2 instances of every team. So, but there's Joshua and there only one of this whole list. This is them. So you have 1 winning case out of looks like 15. So this is choice A. You can do it. I mean, so this is the point. I mean, a lot of people don't love probability, but a lot of those are the same people who are not open to the notion of just making a list. A lot of people are like, nope, not going to do it. You should be willing to do that. It's the thing. All right. Any questions? So, okay, as I mentioned, we're not going to super emphasize that, but we can just quickly outline how that would work. What's interesting about this problem is that the answer choices are not very well written. Because, I mean, the one thing that most people are looking for here who don't find it is 1/30th. Like, a lot of people think it's just 1/6 and 1/5. But, I mean, here are 2 outlines of so-called textbook solutions to this problem. By the way, if anybody cares how I would personally do this problem, I would totally just do that. I would just make a list. Because I would be like, dude, 6 people, pick 2. I can make that whole list in 10 freaking seconds. I'm just going to do that. Lazy. But you should be able to, if you have more approaches, that's always better. So one way you can do this is to realize that your first choice can be either Joshua or Jose. So that's 2 out of 6. And your second choice is the other one of those 2. So and means you multiply, and then that would be 1 out of the remaining 5. So that gives you 1/15. You can do that. There you go. Okay. The second is you can have Joshua first, Jose second, or vice versa. Notice that when you multiply probabilities, you are always taking order into account. There's no way to avoid that. So 1/6 times 1/5, and then this is also going to be 1/6 times 1/5. So this is going to be the same as number 1. And you can also do what I don't remember these formulas per se, like with the exclamation points in them, but so let's make it 3 outlines. So you can also figure out the total number of, because what this is going to be how many ways can I pick 2 people of 6. So this, if you wanted to calculate this, it'd be 6 for the first person, 5 for the second person, and then because you don't care what order they're in, then 2. I mean, in my book, this is a lot harder than just making a list of 15 things. But again, you should be able to do both of them. You shouldn't really have a preference. You should just be, I can do all of that stuff. So there, we've got a zillion ways to approach it, which is the point. Any questions? Alrighty. Cool. Someone is typing. Let's. If you can type your question nice and fast. My way makes it. I mean, yeah. Again, you shouldn't really be ranking methods. You shouldn't have a favorite. You should just have lots and lots and lots of things that you can try. So, having a favorite is not great. Because in practice, having a favorite usually means that people just don't do anything else. Oh, yeah. Okay, thanks for reminding me. This question. So one of the things that most of the probability questions in our Manhattan practice tests are among the oldest questions in the software. And one of the things that they didn't really do the way they should have is the size of the numbers. Like you'll notice that, like in the Manhattan GMAT practice tests, the numbers are often too big. On the other hand, GMAC doesn't really do this. Like this is on our list of things to fix. But GMAC almost always, unless the problem is very, very simple, GMAC just about always gives manageable numbers. When I say manageable, it means you can make a list. For example, there's this problem in the OG where I'm just going to paraphrase, but there's a problem in somewhere around the middle third of the OG problems. It's like, there are 8 teams in the league, and each possible pair of teams plays exactly one game, blah, 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 how many games. I mean, the point, though, this is technically combinatorics and not probability, but the point is that they chose 8 for a reason. I mean, this is not an accident. Like, notice that this number is big enough that you have to get started right away. I mean, this is big enough to avoid being too easy. If there were only 3 teams, it would be 1 versus 2, 1 versus 3, 2 versus 3, and I'm done. You wouldn't even have to be organized. But the more important point here is that it is absolutely small enough to count, with it well under a minute. This is what they generally do. So you can count on this being an option. The only time I've really seen it not available is when it really is simple. Like, how many ways can you make a license plate of 3 letters and 3 numbers? Well, 26, 26, 26, 10, 10, 10, that kind of thing. So, yeah. So thanks for raising that point. The point is you can do it. I mean, almost every probability in the official problems you can do that. So, yeah, it's pretty sweet. I mean, it's my first way of doing anything with random complexity, especially. So, because the point is the thing that's sort of ironic about this is that making a list, if they give you a bunch of restrictions on stuff, making a list gets easier because that means there are fewer things to list. Whereas the more restrictions they give you, it gets harder to calculate stuff. But it actually gets easier to make a list. It's pretty cool. Try this. Yeah, well, it shouldn't be so big. Okay, at this point, we should be pretty much done, but fewer than half of you guys have answered the problem. Remember, the key skill of time management here is just admitting to yourself, oh, stuck. I mean, that needs to happen right away if you're stuck. It needs to be like driving a car to some destination where you're already late. Like, think about how quick you would be to pull over and look at a map or something. Like, you would not guess which way to drive. I kind of go on and on about this in some of the other study halls. The reason why people have such weird instincts to just keep going random ways with stuff is because partial credit in school, they used to reward you for that. And ironically, they used to punish you for admitting that you didn't know what to do. It's not great. But there's no partial credit on this test. Yeah, if anything, there's negative partial credit in the sense of lost time. So you just got to pick a thing. And I mean, you don't have to quit right away. You can try other stuff. So we are definitely all over the place here. I mean, here's where we are right now. Notice there are still 11 non-responders. I'm one of them, so that doesn't count. But you guys got to answer the question. There's only 2 people with the away button. You have to guess. Just guess. G. Barker K. Amelia AKS Icebreaker. Glycine. Maybe you're not glycine, but it looks like amino acid. H. Yeah, to answer the question. Okay, there. Remember that picture I showed you? They're underneath your name. Here, I'll put it back up for a sec. Here's the picture of where the buttons are. I don't know why it's so big, but there. There's the picture. Okay. When you're stuck, are there go-to methods that help you get on track? I mean, it kind of sounds like, okay, G. Barker, you should be able to see that picture now, so you should know where those buttons are. All right, underneath your name, where it says letter A. Okay, let me. I'm going to take this away. All right. Yeah, I see your answer. Okay. Let me come back to that problem in a second because I'm kind of curious about this. When you're stuck, are there go-to methods that help get you on track? I mean, if on track means like definitely going to solve the problem, then believe me, if I had those methods, I would be very, very rich. Riz 2, I have not any idea. I have no clue. It's probably somewhere in the preferences. Deactivating prompts. I mean, what the best advice that I have for this would be, what I would suggest that you do about that is just resize your screen so that the prompts don't appear in front of the screen. That's when they appear in the gray space instead. My best advice for this is that checklist on the other page is the best advice that I have. Because at least that will suggest other ways to approach the problem. But if you're stuck, you need to admit that you're stuck. You need to not bang your head against the wall. It's kind of the best answer I have. This is kind of a non-answer. All right, well, here's a checklist. And then someone in the chat box is kind enough to explain how to deactivate the alerts. Okay. Out of these things, what's going to work here? Absolutely. I mean, backsolve. This is like the most perfectest backsolving situation ever. And I guess you can make a list, of each year as part of that process. Absolutely. So you can kind of combine these together into an approach. So, sure. Just kind of back solve by making a list. So let me smallify that a little bit. Yeah, smallify it. Okay, so yeah, let's just make a list. Organization is your friend. So year, number, and then height. And it's always the end of. So this is the end of, and this is the end of. So let's just put that in there. I am outside. If you guys have a super hard time hearing me, I can move, but it would. No one said anything yet. All right. There, yeah. I mean, I live in the middle of downtown, so there's a lot of noise. Okay. End of year number and then height, and then let's back solve. So let's say we take. I mean, this is going to be the same column every time. And then what's supposed to happen, I mean, okay, this is sort of weird the way they wrote this. 1/5 taller. Can someone help me out there? Yeah, just read this as 20% taller or 6/5. I mean, I would go to the percent first, and then that's where I would get the 6/5 from. This is the same as, because 1/5 is 20%. So, there. So this is going to be the same thing as 120% of. (1.2 times or 6/5 times. I mean, those are all the same thing. And this is another kind of flexibility that you should have too, where you can do any of these interchangeably. Okay. So that's what's supposed to happen here. I mean, I remember when I first saw this problem, I read it as 1/5 of a foot taller, because that's what it looks like to me. But the thing is that you can dismiss that really quickly because all of these choices are bigger than 1/5, and you're doing 2 years of growth. So, like, even if you use the smallest number here, you're still growing by 0.6 of a foot. So. Yeah, if it's misunderstanding the problem, then it's more of you probably need to slow down more. That's usually where that kind of comes from. But yeah, so what you're looking for, the goal of back solving, is that the bottom row should be 20% more than the top row. So absolutely. Bottom yellow should be 20% more than top yellow. Okay, let's pick a choice. What might help there would be there's a couple of sessions on word problems in general, just talking about how to better approach those to enhance your understanding, and then you might want to check those out. Because that's the point. A lot of people get confused pulling words out of paragraphs. So the word problem approach will help you with that. Give me a choice. Let's start with a choice. What's a nice choice to start with? Yeah, I like 1/2. I mean, 1/2 is a very friendly number, so it's a lot friendlier than 2/5. So the height of the tree here at year 0, this is always 4 feet. But now this is where we start using the choices. So if we take choice C in blue, then that's going to be 4.5 feet, 5 feet, 5.5 feet, 6, 6.5, 7. Okay, so 7 is not 20% more than 6. Now, if you don't know which way to go, so you can definitely strike choice C. If you can figure this out really quickly, then you should do it. And by really quickly, I mean substantially less time than it would take you to throw in another choice. Basically, all right, this is less than 20% over that. It's because it's only 1/6 more. It's supposed to be a fifth more. So what that means is that you're not increasing the height by enough. Like, for instance, if you went up by 0.1 every time, then this would only be, what, 4.4 and 4.6. They would be almost the same height. So the faster the tree grows, the bigger the percentage will be. Right now the percentage is too small. So we can actually eliminate B and A as well. Because we need the tree to grow faster. Now, again, do not spend more than like 4 seconds thinking about that. If it takes you longer, then it would be more efficient to just throw another number in there. Because like even if you went the wrong way, like one student says 2/5. If you do 2/5, it'll be an even smaller difference, and then you'll be like, oops, wrong way. Easy. So don't waste your time thinking about this. Like unless you realize this right away, then just plug another choice. Okay. That was the whole preceding discussion of the tree is not growing quickly enough. If that doesn't make instant sense, then just plug in more numbers. Just do the back solve. Between 2/3 and 6/5, does either one of these look like don't do it? Yeah, right. Because that's where people are ignoring everything except for the 1/5 increase. Yeah, don't do it. That's where you're just pulling random numbers out of context and using them as the answer. Don't do it. Yeah, this is not going to fly, right? Like, let's see here. Pulling random numbers completely out of context and using them as answers. That's not smiley face. Don't do it. All right, but as far as actually back, so I mean, I'm going to try D because D is the one that doesn't do that. So let's try D. D is our friend. D. Let's do in that color. 4. That's going to be like 4 2/3, 5 1/3, 6, 6 2/3. 7 1/3, and 8. And then we would probably want to, Riz, when the recording comes out, you can rewind to that part of the discussion as far as which way. But the most important thing about that is if you don't see it right away, then you don't even care. That's the most important part. That's why we're not going back to this. It's not me being a jerk. It's you just don't care unless it is instant. Because you could plug in B or A in about 5 seconds. Okay. Efficiency is the name of the game. So here, this is 6 2/3 to 8. So that's the same as 20/3, and that's 24/3. And that is actually a 20% difference because that's 20 and 24. If you subtract those, the difference is 4. 4 out of 20 is 20%. So you win. There, it's a thing. This is a 20% difference. Okay. About that. For someone like me, who's just starting out, this question is not very hard to answer, believe it or not. Alright. Hopefully you're not one of those super dead serious all the time people, because if you are, my answer is going to annoy you, but I'll take that risk. Should you spend a lot of time in practicing theory? Yes. Should you develop speed and comfort with back solving? Yes. There's your answer. Yep. That's the answer. Double yes. I mean, you just want to be greedy with solutions. You want to have like lots and lots of ways to do it. I mean, if you can solve math problems by sticking voodoo needles in dolls, you should practice that too. Like whatever works, do it. It's a thing. Let's see. This one's question right here. Is it important to practice always with a time constraint? I mean, I would say if you are a total beginner, or if you're trying to build a skill set that doesn't currently exist. What I mean by the second of these things is, like, let's say, for instance, that you are used to doing word problems by just scratching equations out onto a page with no chart or anything. So then that would be a totally non-existent skill set. So, like, learning to organize word problems into charts if you've never done that before. So in other words, if you're doing something totally unfamiliar, then you don't need to worry about timing, is the point. It's like learning new dance steps. So then don't worry about time. But once the skill set is in place, then timing becomes more important. Because, I mean, okay, here are two things that humans cannot do together. Number one, get better at something. Number two, get faster at it. Cannot do both at once. If you don't realize this is a thing, just think about, like, dance steps. I mean, if you learn a new dance step, that's going to be really slow while you are learning it. And then only after you are decently comfortable with it do you start speeding it up. It's the same sort of thing here. So, like, think about when you would speed up dance steps. That's, you know, not when you are very first learning them, and not if you're doing the tango when you've only done the salsa. But then once you know the steps decently well, then you start working on timing. It's the same sort of thing. Okay. Let's see. Yeah. Let's see. I don't know how peyote would help you with math problems. You probably just be seeing all kinds of things that weren't in the problem statement, so to speak. Let's see. Okay. Yeah. All right. So it seems like that discussion. I mean, it doesn't matter what I prefer because I'm not you. So the point is that you shouldn't really have a preference. So yeah, they're things. We should be able to do them. So if we go back to this. All right, there we go. I mean, you can also do this algebraically if you want to. I'll give you a super quick outline of that. In fact, I'm going to be super lazy and just append it onto the existing chart. Here. Let's talk about algebra. I'm just going to give you a quick outline of that because, again, that's not the point of today. So, but I'll just outline it for you. If you're going to do algebraically, then this is 4, and then the point is that you should make some sort of letter for the variable for the amount that it grows every year. So say it grows by g for growth feet per year. So then this is going to be 4 plus g, 4 plus 2g, and so forth. This is not the only way to do this, but it's a thing. So, yeah. And then you can set this up as 6th year is 20% more than 4th year. That's the requirement. So 6th year is 4 plus 6g. And then you can use 1.2. You could also use the 6/5. whatever. That works too. So either way, the point today though is to do the things that are not straight algebra. So that's with an outline. That's how you do it. There it is. Okay. You would get the 4.8 would probably be in front of the. It wouldn't be 4 plus 4.8g. It would actually be 4.8 plus 4.8g. So you would have to multiply this by both parts. Okay. Cool. All right. Let's look at another one. Let's find a fun one. How about this? So this is not multiple choice, so you're not going to have the same backup methods or what have you. But with data sufficiency, there's really only one major alternative method. If you've sat through enough of these sessions, you'll know exactly what I'm talking about. But we'll put it on the screen here in a moment. But go ahead and give this a shot. I'll be right back. They will give you conversions. Yes, they will. So that should be provided. They will definitely provide that. There, 5,280 feet. I mean, they even provide basic metric conversions. Like they even tell you things like 1 meter is 100 centimeters. So they will definitely give you that piece of obscurity. Yeah. Because, you know, no one else in the world uses English units, so, for sure. You do need the conversion, because there's miles in the question. Okay, let's pick a thing. And let's go with it. At this point, if you're still working, actually this has been true for some time now, but if you're still working, you should definitely be positive that you're going to get it right. Okay, so if you've seen any of the number of these videos that deal with data sufficiency, then you've probably seen this graphic a number of times. This graphic right here. Ooh, it's so big today. Here. So any data sufficiency problem, there's basically two ways to do. Where your typical textbook approaches are one thing, but then testing cases, you just plug in specific cases of it, is the other. So I mean, there's not like a billion zillion alternatives like there are with multiple choice, and that's a plus and also a minus. It's really both. I mean, there's only two options. Obviously, that's a negative because you don't have as many options. But for a lot of people, it's also a positive in the sense that people, when faced with too many options, a lot of people seem to get this decision paralysis thing going on. Like where there are just so many options that I don't even know where to start. I mean, we've seen a little hint of that in the chat box where people are like, I don't know where to start. See, here it's not really a thing. If you can't figure out one of them, just do the other one and that's it. Also, the rationale for this is explained more in some of the other sessions if you want to check them out. But the goal of testing for specific cases is to get not sufficient, which means, in other words, that you're making two different things happen. So, because that's a concrete goal. I mean, if you sufficient means I can't get the other thing to happen, which is not what you try for. So, let's try this with just testing cases. So, we are going to have to convert this one way or the other because you have mismatched units of distance. You have miles, but then you have feet. Which way do you think we want to do that? Do you think we want to convert miles into feet or feet into miles? I mean, it could work either way, but I would go with miles to feet, like MH says, because there's two advantages of going that way. The first advantage of that is that you don't have to deal with weird fractions whose denominator is 5,280. So no weird fractions. But also you only have to do it once rather than twice, because the feet are in both statements. But notice what's more important is when you review the problem, you should be able to do it the other way too. You should actually be able to turn these into miles. Yes, it will kind of suck, but that should be part of your review, is doing it the other way. Just to get a sense of whether it's doable and how doable is it, what are the obstacles. And even maybe it might even point out some stuff for you to work on. Like if that just kills you, you might have to work on fractions, for instance. So, okay, but 6 miles is here, I'll work it out. It's about 31,000. It's worth 3,168. I mean, you should be able to round these off a little bit, but be careful with that. It's better not to round them. Okay, so let's test cases. How many cases are we going to have to try for each one? For each statement, how many cases are we going to need to try? Well, remember, not one, because it's data sufficiency. You can't just test one case. Okay, someone said extreme values, plural, so that means 2 cases. Right, no, it means the smallest possible and the biggest possible value. So, I mean, because one case will make everything look like it's always sufficient all the time. You know, because the only way to get not sufficient is to try 2 things and have them have different results. But yeah, that's the point. Extremes are the point. So try extremes. That's all we need to try. Because if the min and max are on the same side of this issue, then everything will be. And if they're not, then not. So, and make sure you organize. Just think about, the organization should just kind of happen. But the organization is basically just think about what you're going to do with the numbers. And then make columns for each major step. And you can organize any testing cases type situation by doing it. So we're going to have, these are statements about speed. So we can pick a speed. in feet per second. So then you're going to have a number of seconds, which will always be the same, but let's still put it there. And then that's going to be time. And then finally, what the issue is. That's not time, distance rather. Sorry. In feet. And then what question are we asking about this distance? Like, what are we going to do with it once there's a number here? What are we trying to do? Yeah, you're trying to see if it is greater than 6 or not. So always make this explicit. If greater than 6, if you can get both of the following, you can get distance greater than 6 miles and distance not greater than 6 miles. Then this is not sufficient. Notice this is why you try for not sufficient, because this is actually a concrete thing to try for. I want to make both of these happen. So get both is not sufficient. Okay, I have goals now. I have goals. All right. Like I said, MH, when you review the problem, you should do it both ways. Yeah, I mean, you can do, if you think of another way, you should just do it. I mean, these things will all work. But, here, one thing that you should not do, this definitely falls under the category of don't do it. When you are working these problems in real time, do not ever do this. Don't second guess yourself. Don't do it. Like if you're reviewing a problem and you're thinking about the relative efficiency of different things, that's one thing. But when you're actually doing problems timed, do not ever think thoughts like this. Because what this will make you do, like basically just if you have something that might work, then just do it. Do not put obstacles in your way. Because if you think thoughts like this, the problem is that you're going to wind up just sitting there staring at it. Even though you have a perfectly workable method in your head, you're going to be busy worrying about, is there a faster method? Don't do it. Because, I mean, the difference is in the time. I mean, even if it is quicker, it's probably quicker by like 8 seconds. You know, it's not going to be quicker by nearly enough time to justify sitting there deliberating about it. I mean, you have to be just reckless about this. Just do stuff. I mean, I put this on the board in a bunch of previous sessions, but there are 2 secrets to success on the GMAT, which are number 1, do stuff. Number 2, don't not do stuff. In all seriousness, not a joke. I mean, like, if you think thoughts like this, that kind of falls into the category of not doing stuff. You should just do stuff. So we might be doing different stuff than you would do, but that's the point. I mean, all of the things that are the most trenchant about this test are the things that sound stupid. I mean, really. So, okay. Speed, right. So with statement 1, notice we should make 2 copies of this chart, which we can kind of just divide it in the middle like that. So statement 1 and statement 2. Okay. What speeds should we try for statement 1? Just extreme. What are the extreme speeds here? Yeah, 16-ish. It can't technically be 16, but it could be 16.0000001. So we can just say approximately 16. the number of seconds is always, what is it, half an hour, so that's 30 minutes times 60 seconds per minute, so 1,800 seconds. 1,800 seconds, 16 times that. And remember, this is the target value, is 31680 feet, that thing up there. So 16 times 18, okay, 16 times 2,000 is 32,000. So 16 times 1,900 is going to be 1,600 less than that, minus 1,600. That's actually already less than this target value. And that's even smaller if it's 18. I mean, the only reason I'm doing this is because I'm very bad at doing this kind of arithmetic straight up. Like, just doing the multiplication, I make lots of mistakes. So the shortcuts like this. This is one of those personal things. If you're good at that sort of arithmetic, you don't need shortcuts like this. If you're not so hot, they help. So this is, but notice this is already less than 31680. So this is less than that. But so 1,800 seconds is half an hour. That. So you have to convert half an hour into seconds. Because these are seconds, and that's not seconds. What's the other speed we should try? Yeah, like approximately infinity. Yeah, like, I don't know, 1,000,000. Or just, lots times 1,800. Like, whoa, fast. There. So that's going to be as big as you want. So this is going to get much bigger than that. So we got both. Not sufficient. They will give you the conversion. In response to the chat box, I mean, this transcription of the problem, they neglected that. But there is no way that the GMAT will require you to know these conversions. I mean, they don't even require you to know how many centimeters are in a meter. Like, even that, they will still tell you that there is 100. In fact, I don't even think you have to know how many cents are in a dollar. I'm pretty sure you don't. Because there was one problem that was in cents, and then they gave you 130 cents instead of $1.30. So, if this is from the Veritas lesson book, then that's not good for Veritas. They don't own the copyright to this problem. Okay, theft of intellectual property, yeah. But notice what the goal is. The goal is to get both of these to happen, and we got them both. Not sufficient. Statement 2, what are the extreme speeds? I mean, one of them is going to be about 18. That's the max. What's the min? Minimum speed? Approximately, whoa, watch it there. Minimum speed is going to be close to 0, close to standstill. So 0, the number, I mean, it doesn't even matter how long you're traveling because your distance is going to be about 0. So this is less. This is clearly less than 31680. Approximately 18 times 1,800. We actually got to work this out because that's going to be pretty close. So if you do that, if you do 18 times 1,800, you get, I'll just have my computer do it. It's 32400. It's more. So that's going to be more than 31680. We got both again, not sufficient. Now, in order to combine the statements, you might have to do new cases, but you might not. I mean, what we should first do is look at the cases that satisfy both statements. So, I mean, whoa fast gets thrown out when we combine because you can't be whoa fast in statement 2. But notice that this other statement is totally legit. I mean, 16-ish is definitely also okay in statement 2. So we can keep this. This works in both statements. So we can reuse this one. It works in both. But you can also reuse this one because 18 is definitely bigger than 16. Ah, we don't even need to do any work. Because you can reuse, I guess let's make that plural. You can reuse these ones because they work for both. That's it. That's enough to prove it. Like even if you combine them, you still have one outcome less than that, one outcome more than that. If you can also do what MH said earlier, you could convert it to a speed problem. If you converted these, you would get some number between 16 and 18. You can do that too. There's a lot of ways you could approach it. So, any questions? So it is E. Yeah, because when you combine, it's still not sufficient. Yep. Okay. Let's see if we can cram in one more. Let's see if I can find one nice and short. And then, yeah. Okay, that question there's no point in answering. If you've seen the previous videos, you'll have heard this spiel over and over again. But difficulty level, absolutely no rationale for ever even sort of considering that. It can't help you. So don't clutter your brain with it. Brain clutter. Okay. I mean, yeah, what Pig 20 is saying is a thing. But also on top of that, if you were told those levels, you would probably perform worse on the problems because you would have extra stress. That wouldn't be so great either. Okay, try that. Can I summarize the whole problem again? Unfortunately, no. But the recording will be posted soon. Check it out now. All right. Let's try to hit this one real quick before we wrap it up. Let's try to wrap it up pretty soon. Here's that list again. It's going to cover the whole screen when it first shows up, but I'll make it smaller. Okay. Okay, I still got a few people without answers. At this point, we should be way done. Oh, the opposite thing. I don't know exactly what that means. Maybe elaborate a little bit. Okay, last question. Oh, also, while you guys are finishing up, this is misinformation. This thing that was posted here. You don't. Nah. I mean, what is this? What is this 2-minute statistic? What does that represent? That's something. It's the average. Okay. So that clearly means that you should not expect to do everything within that time. In fact, think about how averages work. I mean, assuming a decently normal distribution, that means that half the problems will take more than this long. So because like, okay, I mean, do not set as a goal, I need to solve every problem within 2 minutes, because that's a terrible idea. I mean, an average is not a maximum. I mean, really, you don't even need to get a sense of 2 minutes as much as you need to get a sense of I am stuck. I mean, because one little secret about this exam doesn't really have time pressure. If there is time pressure, then you are responsible for that, not the exam. Because like, there's only time pressure if you sit there and stare at things when you are not making progress. Then there's time pressure. But if you're like, nope, not working, I quit, I'm going to try something else, if you are just absolutely no patience, no perseverance, no tenacity, you will not have time pressure. That's a promise. Like all those charts of minutes, seconds, all that stuff, you really don't need those anymore once you have the self-discipline that I'm talking about. So you will have no idea if the difficulty level is rising, so that is irrelevant. And also, it's not a thing with difficulty anyway. I mean, the point is that really long problems, I mean, again, see, okay, guys, time management is total common sense. It's total common sense. Like if you paint houses with a crew and you take an average time of 4 hours to paint a house, I mean, everybody's going to realize right away that big houses will take more than 4 hours, and tiny apartments will take less than 4 hours. But this is the same thing. I mean, long problems with lots of stuff in them will usually take longer because they take longer than average. Short problems will take less time. Also, don't confuse this with difficulty level. There is no correlation between length and difficulty. In fact, in data sufficiency, the harder problems are slightly shorter on average, not longer. The problems with all the words in them are actually towards the beginning of the section. But you won't know, so it's not going to matter. I mean, again, the skill you want to develop is just total brutal honesty about I am stuck, time to quit, try something else. I mean, don't worry too much about minutes and seconds. But there are some problems that no one should take more than 20, 30 seconds on. There are other problems where everybody's going to take 4 minutes. It happens. Averages are averages. I mean, just import your common sense notion of an average and you will be fine. But don't think these weird classroom thoughts. Okay, I mean, let's talk about this. We're over time already, so I'm gonna compress the discussion here a little bit. But you can't plug in because nothing is unknown. So plug in is a non. You have to have things that are undetermined to plug in. You can't really. Well, can you back solve? Let's see. Maybe. That might work because, you can certainly go somewhere from that. Common sense estimation, sure. Make lists, there's nothing to make a list of. So that's gone too. Alright, so let's just do plain old common sense estimation. I mean, okay, it's not drawn to scale, but so on your paper you should try to draw it to scale. If you think about it, the 1 foot diameter, so those circles are way too big in that picture. Because that's supposed to be 1 and 1, and yet that belt is supposed to be 15. I mean, the way they drew this, there's no way. This looks like it's 3 or 4, and then 3 or 4. So what it really looks like is the same deal, but with smaller circles. We don't need to be incredibly exact about it, but the circles won't be the circles will be smaller relative to the straightaways. So you're going to get something that's like roughly this. Okay. Looks like that. All right. Common sense estimation. We ultimately want the distance between the centers. But one thing that might be easier to think about at first is just the whole distance from end to end, which I'm going to do here in pink. I mean, tell me a story about the pink distance. That looks like a little cartoon character, right? Frog eyes. Tell me a story about the pink distance. Anybody? Can you put a boundary on that? Remember that this whole thing was 15. Okay, let me put an orange. It's good, yeah. Well, so the orange distance is 15 over 2. So it's going to be less than that, but not by a ton. Right? So the pink distance is a little less than 15 over 2, 7.5. And then the green is you're just taking exactly 1 radius off of each side, so it's exactly 1 less. So a little less than 6.5. All right, there you go. Those are common sense estimates. Eyeball it. Just do the same way you size up a parking spot. Well, okay, pi is about 3. So this is about 12 over 2. This is about 6. I mean, that's pretty good. This is 15-ish over 4. This is about 3.75. There's absolutely no way it's that small. 15 minus 6. This is 9-ish. I mean, that's bigger than 7.5, so that's impossible. And this would be even bigger than that. This would be about 12, which is twice as big as it should be. And then this is about 6 as well. So you have 2 choices that survive. Now, if you look at choice E, you should realize that something is a little bit fishy about it, because it seems to not care how long the conveyor belt is. Because there's no way you're going to get the 15 to combine with pi. So there should be a 15 in there somewhere. Because it obviously matters how long this is. Like if this was 19 feet instead, then everything would get longer. So this doesn't make sense that there's only a pi term in here. Like this choice doesn't contain anything that corresponds to the actual length of the belt. So that's not going to work. So it's got to be A. I mean, E is not ridiculous in terms of the actual length, but E doesn't make any sense because we've got to have a 15. So you can do that, sure. You can common sense estimate. Let's see, can you back solve? I don't know. Let's just think about it. I honestly don't know if you can back solve it. Let's find out. Let's try to back solve this. Okay, so let me take that diagram from the last page with the colors on it. Because if you back solve, that means you're starting with the green distance. So then you can find the pink distance, and then you can find the orange distance. And the orange distance is supposed to be what? I mean, if this back solves correctly, then what's the orange distance? Yeah, it should be 7.5, right? Because it's half the belt. So you're going to answer choice is the green. Yes, you can back solve, right? Add 1 foot. That's going to give you the pink distance. And then that's going to be orange distance. Can you find it? Well, because notice the green distance you can also put. I guess you don't have to do the pink distance. The green distance is also up there, because this is a rectangle. So we don't need the pink. Instead, you can realize that the orange distance is, there's a quarter circle, there's a quarter circle. So that's half a circumference. That's half pi. Pi over 2. That should be orange distance. And that should be 7.5. Okay, so if you pick A, might as well start with that, right? So that's 15 minus pi over 2. Oh yeah, this is totally going to work. So if you plug that in there, then if you add that to a half, then that's going to fly, right? Because this is going to be, that's supposed to be a pi, not a 1. 15 minus pi over 2 plus pi over 2. Well, those are going to go away. And you have 15 over 2. So, yep, we win. There you go. Okay, that's a thing. I got to run here, guys, but that was like way over the time, but it's cool stuff. And there's an algebraic way posted in the window for your convenience. No, thanks for that, BK. Sweet. So we might, depending on what gets submitted or not, we might do some more of these next time, because I do have some more left on the slides. But we'll see. We'll see what we have some time to do. All right, guys. Thank you. Good night and good luck. I am going to kill the recording at this point.